Hi class, this is Dr. Frank again. This is the chapter 7, section 7.1 video. This video will be in two parts or two segments. So this is part A. Part A, I will go over the theory behind this and the formulas in this section, and also part B will be examples to explain the concept. Okay, so our objectives are the following. In this video, we'll talk about the point estimate. And in this case will be the sample proportion, that's a p-hat. And it's a best estimate for the population proportion. We also will talk about confidence interval, and then margin of error in that sense, and also finding the sample size. Suppose you want to conduct a research, how will you know the sample size to choose? Is it going to be too high, too much, or too little? Okay, so we'll be talking about that. So what is a point estimate? Okay, a point estimate is a single value used to estimate a population or parameter. And then from section 6.6.3, we know that some of these estimators are biased, some are unbiased. And those unbiased examples are the population proportions, sample proportions, and then the sample mean, and the sample variance. So by this video, we're talking about the proportion. So a point estimate basically a single value. In the case of, say, p-hat, p-hat is it could be an example of that. Okay, and you can have let's say p-hat. You can have a p-hat, or you have x bar as a single value, or the sample variance. Now, for example, let's say a Gallup poll was taken in which 1,487 adults were surveyed, and 43% of them said that they have a Facebook page. Now, based on that result, find the best point estimate of the proportion of all adults who have a Facebook. Okay, so in this case, my sample size N is 1,487. And it says that 43%, okay, 43% said that they have what? They have Facebook. Okay, they have a Facebook page. All right. Now, if I take 43%, if I want to know the number of successes, okay, it will be what? 0.43 times 1,087, which in this case will just be what? 0.43 times 1,487, and which is approximately, this is a 639.41. Okay, since the sample size, we're going to round it up to 640, right? Now, my point estimator, proportion or estimator, which is sample proportion, is given by this formula x over n. So which in this case will be, x is the number of what? My successes, okay? Which will be 640 over what? 1,487. And this will give you approximately what? The 4.43, or in this case 43%. So my point estimator for what? The population proportion, okay, is given by this formula, which is what? Okay. So in this case, we say that because the sample proportion is the best estimator of the what? Population proportion, we conclude that the best point estimate of the population proportion, or the true proportion, is what? 0.43. Okay. And as I've explained in the previous slide, this is the what? how to calculate the p-hat, where x is what the number of successes and the n is what your sample size. Okay. Now, confidence interval, also called the interval estimate is a range of values used to estimate the true value of the population parameter. Okay. Now, population parameters we know could be what? The proportion p. It could be what? Mu, which is the population mean, or the population what? Standard deviation, or the population what? Variance. Okay. These are what we call the what? The parameters. Okay. These are the parameters as over here. All right. So we want to find an interval that if I'm given a sample and I estimate I want to know the parameter, which is always difficult to find. We want to give an interval for it, and that interval is what we call the confidence interval. So now we also need to talk about what is confidence level. Okay, at what level are you confident that the true value of the parameter will lie within a certain interval? And we use this formula. It is 1 minus alpha. Okay, so we can have 0.95 or 95% confidence level. Okay, and that is the confidence that actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. Okay, so the confidence level is also called the degree of confidence, or the confidence sometimes called the confidence coefficient. Okay, now alpha is a small value, which we'll be explaining in a minute. Now, any confidence interval could be expressed as what? A point estimate. Okay, a point estimate, and then what? A margin of margin of error. Okay, so when we want to find a point confidence interval, when we know the estimate, the population parameter we are dealing with, we can always express it as what? The point estimate plus or minus what? The margin of error. Okay, so now these are some of the examples that if I have the confidence level of say 95, what is my alpha? Now remember, what's my confidence level? Okay, between confidence level and then what's the relationship between them? Okay, confidence level and then alpha. We know that this is what? 1 minus what? Alpha. And so if I have a curve, the density curve, which is like that, okay, the middle is your what? It is the confidence level that we talked about. And then the tails, if you add them together, you get alpha. So that when we add everything, that should be, what do you call it? 1 or 100%. So each tail is alpha over 2. Okay, over 2. That is this part. Right. So if I have a 90% confidence level, what is my alpha? If I subtract the 90 from 100, I get what? 10. That's why we got this 10. If I have 95, my alpha is what? 5%. So that means that we have what? 2.5% at the tails. I have a 99%, my alpha is 1%. Meaning we have what? 0.5% at what? At the tails. Okay, so that's the relationship between the confidence level and then what? The alpha. When you have a confidence level, subtract from 100, okay, which because it's always expressed as a percentage. Now, it is important to know the right way to interpret this confidence interval. Okay, so assuming that we are given the confidence interval for a proportion, or that the true proportion as this, and we're always going to round this to 3 decimal places. Okay, what is a 95? How do you interpret a 95% confidence interval for this? Say that this is the correct way is say that we are 95% confident that the interval from 0.405 to 0.455 actually does contain the true value of the parameter, in this case, which is a population proportion. Okay, if we repeat it a number of times. Okay, the wrong interpretation is that it is not that you have 95 chance. It's not a probability that a true value will fall into that same interval. Okay, so note how we interpret the confidence interval and then the wrong way to do that. All right, here we just did, excuse me, we took 20 samples, okay, for this same confidence interval, which we got between what, 0.45 and 0.55. Okay, now here we assume that the population true value is not given, we assume that it's what, 50%. So which is the 0.5, okay? So now, if we read 20 different samples and we compute it, we realize that for 95%, okay, for 95% confidence interval, it means that 95% of the samples of the true value of the proportion or the parameter will lie within that interval, 0.45 and then 0.55. Now, as you can see, out of the 20, there's only one of them, okay, this one, that didn't contain the what, the 50%, okay, which is the true value. Now, that means that 19 out of what? Out of 20. Now, if you calculate this, you get what? 0.95 is that. And that's the same as saying that is what? 95%. That when we could repeat this process of times, we have 95% of them will fall within that interval. The true value will fall within the interval. Okay. So we also need to talk about what we call the critical value. Okay. Now, remember we have talked about these critical values before. Okay. When we were given, if you remember, when we were given Z alpha, okay, we said that the critical value is a Z value such that we have what? Alpha area to the right. Okay, and this is what called what critical value. But here we have what? 2. We call this as a one tail. That is the right tail, or the alpha is on this side, or is the left tail if the alpha is on the other side. Okay, now this is in case of confidence interval, we're dealing with what? Alpha by 2 on each side, so that when you add them, you get alpha. The middle is your 1 minus what? Alpha. Okay, so if my alpha is 5%, my middle is what? 95%. If my alpha is 10%, then my middle will be what? Will be 90%, and so on. Now, this Z alpha by 2 is what we call the what? The critical value in this case. This is for the 2 tail. Critical value. All right, now, here's examples of finding the critical value alpha by 2 corresponding to what? 95%. Okay, so first, we know our confidence level is 95%. And so we subtract this from what? 100 to get my alpha, which is what? 5%. Then divide alpha by 2. You get 0.00125. Okay, now if you subtract this 0.025, that gives me, okay, this area here, the shaded part is 0.025. So what is the area to the left? Okay, remember if you're using the table, it gives you what? That value. So basically we are going to find, okay, this area here, we subtract this from 1, that gives me 0.975. So if I go to my table, I'm looking for the Z value. Okay, this is Z alpha by 2. We need to determine this value. We want to find this area, which is what? 0.9775. Now, when you find this value, you recognize that it's going to be 1.96 exactly. Okay, so this is my what? Critical integral value. And because it's a symmetric, we have the same but negative on the other side. Okay, so now these are some examples. If you calculate it, we have been doing this before. Okay, so for a 90% confidence level, right? Alpha is what? 10. What is the critical value? That is Z alpha is what? 1.645. For 95%, it is 1.96. For 99%, it is 2.575. Okay, so if you can memorize this, if you can always remember that. So a 95 confidence interval, the Z alpha, the critical value is what? 1.645. And we can use the table and use what do you call it, the start crunch to find the same thing or the same values. Okay. Now, we also need to talk about confidence margin of error. So, because if I'm going to find, if I'm going to find the point estimate or the confidence interval for proportions, the margin of error is denoted by the letter word E, and is given by Z alpha by 2 times, times the square root of P hat times Q hat divided by what? N. Okay, now don't forget the P hat is what? It's a probability of what? So probability of success. And then your Q hat is given by 1 minus what? P hat. Now probability of success is given by X over what? N, where N, X is your what? Number of successes divided by the sample size. Okay, so that's how we calculate or we estimate the confidence, the margin of error. Okay, now notice that this part here is nothing but its estimated standard deviation of the sample proportion. Okay, all right. Now, to calculate the confidence interval to estimate the population proportion, our objective is to find the interval, okay, that will contain the P. That's our objective. Now, our goal or the process is this, or requirements. We must first, these are 3 requirements, is very important. First, the sample is a simple random sample, meaning that every individual in the set, has the same chance of being selected. And then we also talked about binomial distribution in chapter 5. And these are the properties of binomial distribution. It has a fixed number of trials, and the probability of 2 possible outcomes, the probability of the successes and failures, and each trial has a probability which is constant throughout. And then these are what? They are also independent. The trials are independent. There are probabilities that are what? Constant, for each trial. And then it has 2 possible outcomes, a success and then what? Failure. And then we also want to stress that at least to use this procedure, at least 5, we should have 5 successes and then what? At least 5 failures. Okay, so if it doesn't satisfy all these 3 requirements, then we kind of use the formula that we are talking about to estimate the population proportion. Okay, so now, what is the confidence interval? We said that we can express this as what? A point estimate plus or minus what? The margin of error. And then it means that the proportion, so the population proportion P, okay, it's P hat minus the margin of error. And then on the right, we have P hat plus what the margin of error, where the margin of error is given by this formula as I explained in the previous slide. Okay, and then we will round the proportion to what? 3 decimal significant what? Digits of decimal places. Okay. So the procedure is that first we have to verify all the 3 requirements. Okay. Verify all the 3 requirements. And then we can use StatCrunch using the technology or the table for the normal, standard normal to find the critical values. Now, once we know the critical values, we can estimate the what? We can find P hat. Okay, P hat is what? Your X over N, or sometimes it is given. All right. If it is given, then of course we don't need to use this formula. But if it's not given, then that's how we calculate the P hat. And then Q hat is what? 1 minus P hat. Okay, then I can determine my what? My critical value, which is that. I'll find a critical value for that. Okay, now once I know my confidence level, which is what? 1 minus alpha, I can find alpha by 2, and then I find what my critical value, as I illustrated to you. So this is the first part of the video. The second part, we'll look at this this example and calculate the confidence interval, the margin of error, and all that. And then we'll also talk about how to determine the sample size. We'll talk about the formula and then apply it to a problem. So the next video will start from this slide. Thank you.